Okay, so we'll get started. My name's Rosemary, and Alan is here as the co-host. The recording will be on our YouTube channel and also on our website. Next month, Alan will lead the workshop on the Planetarium Educators Workshop series. It will be on organizational patterns, and that'll be Friday, March 27th at noon Pacific. So noon Pacific, and that's 200 UTC, excuse me, 20 UTC. There's no set time limit. We'll pause at the hour and let people leave if they need to, but we sometimes carry on. So today we have Ron. Ron Proctor is a motion graphics designer with NSF NOIRLab. And for over 2 decades, he's directed and produced a number of planetarium films, both in the planetariums where he previously worked, the Ott and the Clark planetariums in Utah. He also has his own company, Proctor Creative, and now he's with the NSF NOIRLab. So he's going to give us some behind the scenes visualizations using Blender.
Thank you very much for that introduction. And it's so good to see everybody and so many familiar faces. I'm going to go ahead and share my screen here. Let's see, desktop. We will go slideshow. All right, we see that.
Yep.
Okay, awesome. Thank you for that great introduction. It makes this screen kind of unnecessary, but that's a picture of me in front of the solar telescope. And I did go to school and I did work and I currently work with NSF NOIRLab. Um, in addition to my work in the planetarium industry, I also did some teaching, and that was between the years from Clark Planetarium until I got with NOIRLab. It was 3.5 years of teaching computer science, photography, and film in Utah and Texas schools. NOIRLab brought me out to Arizona in October of 2023. Whoops. One of the main things I want you to take away from this presentation is that there are a whole bunch of awesome resources available for you at our website at noirlab.edu. And all that stuff is for free, or in other words, you've already paid for it. Um, and the resources that are available there come in the form of full dome images, so here's what our website looks like when you go there. You can click on images, you go to categories and select full dome, and you'll be faced with a whole bunch of awesome full dome pictures. You can go to videos, click categories, select full dome, and you'll be faced with a whole bunch of full dome videos, including some full dome films like Messengers of Time and Space and others. You can download those for free and use those for free, even if you have paying audiences. So a whole bunch of great resources there for you to use. So who is familiar with, or do we have people who are familiar with this plot? I can't see everyone, but I hope that some of you are. This is the DESI 3-year data plot, and this is one of the things I'm most proud of for my work with NOIRLab. This is a map of the galaxies in the universe, and it's a map that's being made right here in Arizona. So Arizona, if you look really close, Arizona is right here in the middle, and right there at the center of the universe. And what's happening is here at Kitt Peak, we have the 4-meter telescope, which has an instrument on it called DESI, the dark energy spectroscopic instrument. And DESI, all night, every night, takes really precise measurements of how far away galaxies and quasars are from us. Then it compiles all that information to make this big map. And I got the awesome privilege of taking their numbers and turning that into something visual. And let me just show you a video of what that looks like when it's rotating. Hopefully this will play well for you.
Looks very smooth on my end.
Hopefully you're able to make out the foamy structure in there. The structure inside there is an artifact of the early universe. Baryonic acoustic oscillations is a word that is used to describe the thing that caused the artifacts. So there was a time when everything was so close together that everything in the universe was touching. And then there was a time when there was enough space that things were not touching. And this shape of the universe, this distribution of galaxies is an artifact of that. And so that's one of the things that DESI is interrogating, is it's trying to figure out what was the early universe like. And also, DESI has made headlines about figuring out what dark energy and dark matter are doing. Let me go back to my thing. So I promised you behind the scenes. Let's go behind the scenes now. So what they handed me was essentially a spreadsheet full of numbers that looks like this. And I needed to turn the numbers from what you see on the right-hand side into data points in a 3D space like you see on the left-hand side. Fortunately, we have an awesome thing called Blender, which is a awesome 3D software. You may have heard of it. A great framework for synthesizing visuals, and it has what's called Python as a back end. So you can take Python scripts and you can write custom code to make Blender do things that it normally wouldn't do. Am I a great computer science coder? I taught a little computer science. That's true, but I'm not the greatest coder in the world. I know enough Python to be dangerous, but I also know how to have a chat with ChatGPT. And so I did that. And between ChatGPT and I, we wrote a little script to turn those numbers into 3D data points in Blender. And it was actually very fast. We did that in about 55 lines of code, and it worked on the first try, just after a little bit of discussion. Next was the artistic part of the behind the scenes here. And I'm showing you this is not the one that went for the Planetarium community. This one actually went into Dark Universe, another film that we made, a flat screen film. But the main point is that those dots become too small for the camera to see if they get too far away. And so I found that I had to dynamically scale the dots with geometry nodes in order to get them to be the right size for the camera to see them. So they would render and you'd actually see a picture. Otherwise, you get a kind of a noisy, fuzzy mess when the dots get too far away from the camera. So I'm hoping that I have made Blender chunky enough that you can read this, but the gist of it is that we're taking from left to right here, we're getting the object position from the camera. We're also taking the position of every single little dot as a array. We're comparing the distance of those things. And then for each little dot as an array, uh, we divide uh, we divide that distance by 2, and then we do a multiplicative factor on it. And then that will inform the actual radius that we draw the dot at. And then from there, we just uh, inform the point cloud as to what each dot size is. The nice thing about this is it's dynamic. So as the camera moves through the field of dots, the dots will dynamically scale. And so dots that are super far away will look the same size as dots that are really close. And it's a problem that I had to solve in order to make this thing look the way that it does. Color, I would direct your attention to that center area there, that color band. That ended up being a choice that was driven by two things. There was uh, a technical need because uh, we at first I wanted this to be done in redshift, or I wanted to suggest it was more red as it got more distant, because everything is expressed in redshift. But the problem with red is that we were not seeing the intricate detail. Red was not giving us the visual that we wanted. We weren't able to make out that foamy structure the way that we wanted to. And so I said, okay, I'm just going to switch to blue and just to see what it looks like. And it looked pretty good. And then I decided, okay, let me make it like the shore of the cosmic ocean. And you've got this kind of foamy white as it's close to the planet or close to the observer, which goes into a deeper, deeper blue the deeper you go into space. And that's the way that maps onto, whoops, I just pretended that was Blender for a minute and tried to click on it. Oh, apologize, I've got the radio. I have to keep the radio on while I'm up here, but they're not talking to me. Anyway, so that maps radially to the point cloud. And then there's also that second color ramp at the bottom, which is a cutoff ramp. And we needed to have, especially in dark universe, we needed to actually cut off the dots that were too far away from the camera. Because we were having problems with the H.265 encoder. When I fed it too many dots, it just would look terrible. And so we found that there was a sweet spot where I could have dots that were far enough away where I could say, okay, just don't draw those. And then I could blend them in at some distance. When they became close enough to the camera, go ahead and draw those. And it ended up being a lot easier on the encoder, and we got a smoother result. So some artistic choices, but also some technical battles happening. Another one that I'm really proud of is the Rubin First Look Planetarium content. I got to, the funnest part of this was getting to see these pictures before most of the world. That is not just a brag, but it was a heavy responsibility. And it was also a heavy, it was also a heavy crunch because almost until the last minute, they were very secretive and wouldn't let me see the full resolution uh, or work with the full resolution until just a couple of days before the release. which was really stressful because I needed to test those those zooms. I needed to see if I was going into the right level, if quality was going to be good. And uh, let's take a look at a video here and also see what time it is. Okay. I guess this one's is this a zoom or a pan? It's a pan. So some of you have used these or seen these. Um, the thing that I realized I was able to do, and I was able to go to Flandreau Planetarium, which is right next door to NOIRlab, for a little bit of testing. The thing I realized I was able to do is that I was able to make the picture into kind of an umbrella shape around the camera. And I was also able to, within some reasonable range, I was able to take the camera from its usual 180 degrees down to 30 degrees and scale it. Scale. I was able to scale that field of view up and down for the zooms in order to give you that zooming effect. So let me just show you what that looks like in Blender. So here's kind of that umbrella shape where we would map on the picture, and then the camera stays kind of put there, but the field of view can change. I found that anywhere from a 30 degrees on up was acceptable in the planetarium. So we could go pretty tight with it and it would still look okay. Okay, Messengers of Time and Space. This is a free planetarium show that you can get and show in your dome. I was the producer for this show. And one of the shots in the show is a gravitational lensing shot, and it looks kind of like this. Let me show you what that looks like in motion. Let's see, do I have, oh, okay, those go away. Okay. Oh, excuse me, I hit the wrong thing. Oh, well, I will not show you that in motion because I got the wrong link, but I will provide the correct links in a follow-up email to our hosts. Let me talk about the behind the scenes here. How do you make this do the optical warping in Blender? Well, we can do that with a special material. And what we need to do, the secret sauce is over here, this green guy, this refraction shader. And what we can do is we can ramp the index of refraction from a non-1 value up until, or down into a 0 value. What does that mean, Ron? Well, let me show you what that means. So here is a plane, and this is the map that we'll use to map to index of refraction. So we have some 0 value down here in the middle, or doesn't have to be 0. It can be nearly 0 or something else, just something less than 1. And then we go to 1 at the edge. So a refractive index of 1 does nothing to the background, and then a refractive index less than 1 does some lensing. So let me go to the next page here, and you can see the result once that is mapped to the index of refraction. I'll go back and forth so you can combine or compare. And once that's in motion, it's not too shabby. Apologize for getting the wrong link. All right. Retrograde motion, something that is hard to help people to grasp in the planetarium. And I find it's helpful to just take a step back from Earth to do that. As you can see in this picture, we have a stick that goes from Earth to Mars and then over to the background stars, and it draws these dots on the background stars. And the way to set that up in Blender is first you need to set up your solar system. You need your orbits to be angled or tilted in the appropriate ways. You also need your planets to be moving along those tracks in the right speeds. And once you've got that, you can take your Earth object and your Mars object, and you can do some magic with those. You can say, okay, Earth, I have a long stick that I want to use to, this is an arrow that was a handy helper that was used for this. I apologize for making it look like a camera. But over here on the right, we have a constraint. That's what this little thing is here, a track 2 constraint. And essentially we're just saying, hey, long stick, we have your base here at Earth. I made the pivot point be at one end of the stick. I made the Earth the parent of the stick so that the stick always follows the position of Earth. But then I said, okay, stick, you always have to face Mars with your z-axis. So it's always tracking Mars with that z-axis, which is the linkage, if you will, that keeps that stick pointing where it needs to point. Then at the end of the stick, we have a particle emitter, which drops those dots. And that's what's producing the video. Let's see if I got a video this time. Oh, I did. Okay, good. Here's what it looks like in a video. Might need to fast forward. No, here it comes. So there goes the stick. Here comes the dots. And when Earth laps Mars, Mars's apparent position changes against the background stars. And I think this is a handy way to help people understand what is going on with retrograde motion. You'll also see that depending on the relative tilt, you get different shapes. So sometimes it's a loop, sometimes it's an S-curve. It just depends on where the pass happens. We'll do one more. So I encourage you to go to noirlab.edu. Go ahead and download all the stuff. You can get not only the shows, but you can also get components of the shows. So if you got Messengers of Time and Space, or but maybe you don't want to show that show, maybe you just want to show parts of that show, you can actually just download chunks of the show. Maybe there's a scene that you like. The retrograde motion scene, for example, you can just go grab that scene and just use that. You can remix that into your own show. Just follow the rules of engagement as far as our attribution goes. It's a Creative Commons attribution license. Just say where you got it from. Give us credit. That's all. So There's my email. Send me email. I will probably answer your email in a reasonable amount of time. And and that is the end of my planned presentation. I'm open for questions.
Thank you, Ron. We'll start off with questions, but I'll start off with mine. The last one you showed with the retrograde motion, was that completely in Blender?
It was.
Was? Okay. Okay. Does anybody have any questions?
I wanted to, this is not exactly a question. It's just something I wanted to say. Well, first of all, that was amazing. Short and to the point and really valuable. And what I especially liked is the fact that you make components of your show available. I mean, in addition to the whole show being available for free, the components are available. That's not something that happens very often. It's something that I really wished that producers would do, make little elements available even for sale. But now here they are that you've done it. Thank you very, very much. That's great.
The credit for that decision goes to Lars Lindberg Christensen. He's the head of CEE, the head of communications. What is it? Communications, education, and engagement here at NOIRLab. And Lars is formerly of ESO. So you'll notice that the ESO website kind of looks like the NOIRLab website, and that's because of Lars brought the ESO ethos over to the States as far as sharing and making stuff available. So big props to Lars. He deserves a huge amount of credit, and he's great to work with.
I just want to reiterate what Alan was saying. In my setting, I have school students from our school district, and I have been told specifically that we cannot use films in our lessons. We can use portions or short things. I say we, it's just me. But so that eliminates a lot of resources. So I am grateful, and I have used things from NOIRLab. So thank you, thank you.
Good. In addition to the full dome material, we also have a lot of flat screen stuff, like well, a huge amount actually. And if you want to watch Dark Universe, which is the newest film, that's about a 15-minute long film. Just go on NOIRLab and search for Dark Universe, and you have to type it that way. Yeah, I always say it that way too.
I get jump in. Hey, Ron, good to see
Yes.
you. I will say I had the pleasure of actually getting to watch Dark Universe at the Phoenix Planetarium in January at the AAS, and I was so sorry you didn't get to see it on that giant LED high contrast dome. Uh, I was wondering what was your kind of end-to-end production time to put that together?
Dark Universe was actually a really fast production, and it was thanks to several factors. So our script development time was pretty fast compared to other projects. So we did a really good job of not having too many cooks in the kitchen, which is a thing that happens with projects. So script development came together really quick, and that enabled us to hit the ground running with assets. Our assets were almost all taken from NOIRLab's website, and they were existing assets. So almost all of those assets were already stock footage that we took from our own page. And so I think that show kind of demonstrates the power of our archive that we've built up over the last few years. But to answer your actual question, how long did it take to go from beginning to end? About 2 months.
Well done.
Thank you. Yeah, it was a whirlwind.
I'll say that it was amazing. The Vera Rubin Observatory first look at the amount of resources that were available, both leading up to that and then at the time of. Um, I mean, there were full dome images, full dome clips, full dome movie. It was just pretty amazing.
Yeah, and there's NOIRLab's team that was producing for that, and then also Rubin has their own entire outreach team as well. And it's the details of this are a little bit sticky, but for a while, Rubin was a separate organization from NOIRLab, but now Rubin and NOIRLab are the same organization. And they have merged since Rubin began operations. So Rubin Construction was separate, but Rubin Operations is under NOIRLab's umbrella. But anyway, what that means is that Rubin Operations and NOIRLab were both producing material for that event. So lots and lots of material.
Ron, you might not be able to see the chat, but Chris Miller just typed in there, let's take a tour. I don't know when that could happen.
Oh yeah, I can do that.
Hey, before you take us on the tour, Ron, I just wanted to say thank you so much for the little walk through the node groups. I really appreciate that so much. That's super helpful for me. I've actually got Blender open right here, playing with some of what you were doing in there while you continued. So thank you very much.
You're very welcome, and thank you, Waylena, for all of your assistance over the years. Waylena has been my mentor in Blender. She's been doing it longer than me, so good job.
And on that Blender note, I just had to jump in and say the rate at which they are rolling out features that are so directly applicable to what we do is amazing. And the fact that you don't even need to use a Python script anymore to import a comma separated value. Like now you can just drag and drop the CSV file in without even using your AI to generate the code for that. It's amazing.
I should have done that. Oh, well, I'm glad to hear that.
It's only, I think in the last 6 months they added the direct import of CSV files, so it's fresh.
Oh, nice. Okay, so they just become a point cloud.
Yeah, it just becomes a point cloud, and all of your columns come in as metadata on each point, and then you can do all your data viz with it. It's amazing.
Well, that would have been useful.
We clearly have some advanced Blender users here. Makes me think that for some Zoom seminars, we could have beginning and intermediate and advanced sessions possibly on things for people who are not as advanced. It's good to have these power users here, actually.
I think that one of the most powerful things you can do is make tutorials, something that someone can sit and watch and play back. And that's something I do when I have time. So I will continue to do that when I have the time.
That's the main thing I know you from is Blender workshops that I've seen, that I flunked, but never mind that.
Well, I'm good for a little tour if there are no other questions at this point.
Absolutely.
Okay, let's do it.
We can still have questions too.
Oh, well, you can ask those. I can walk and talk. Hopefully this squeaky cart doesn't bother anyone. Let's see. So we're not going to go in order, but this room is called the eToys Garden, and this is maybe this is an appropriate place to start because the mountain here that we work and some of us live on is Otham land. This is land that is owned by the Tohono O'odham Nation. And in 1958, this National Science Foundation struck a deal with the nation to make the observatory happen. And as part of that deal, every building on the mountain needed to serve a purpose. And so when this building stopped doing science in 2017, its purpose was lost. And so it had to either be bulldozed or it needed to be repurposed. And so it was decided to take the McMath Pierce Solar Telescope and turn it into a science center. This is one of the rooms in the Science Center, and it's a room that's dedicated to O'odham culture and art. And currently we're featuring some poetry on the wall. This poet works in English, O'odham, and Spanish. The other wall is waiting for its art. There are some high school students that have some photography that's going to go up there very soon. Our liaison with the nation is organizing that project right now. Many of you have one of these things.
Ron, putting your camera on the cart like that is brilliant. That's a fantastic cinematic effect.
Well, good. This is my favorite planet. It's the one I'm currently standing on. This is our Science on a Sphere. And this is on one end of the Science Center. So if you're familiar with the McMath Pierce Solar Telescope, there's the heart of the telescope where we started. There's two wings essentially. And I've taken you down one wing. At the end of one wing, we have our Science on a Sphere theater. This was installed in 2023, but most of the other exhibits were installed in December. Let's make our way into the control room.
Ron, I had a real quick question. What's your altitude?
We're close to 7,000 feet here. Here's the control room facility. We've added some glass around the controls because we are trying to get the heliostats working again. But there is the control panel for the heliostats. There's I think it's a PDP-11 is what it's called, that computer back there. Let me grab a keyboard. I'll show you what I've been working on. So this table is showing a picture of the sun in hydrogen alpha. And I've made the app that brings in the pictures that are showing what is on this table. So folks can gather around and see a current picture of the sun in many different wavelengths and also a magnetogram, which is pretty neat. So using the keyboard controls, our docents and guides can show what the sun is doing currently and in several different wavelengths. I'm also working on a sonification for this, so it'll play some kind of ambient music based on the picture, but the computer is not cooperating with me, and I am sad about that. And I don't exactly know how to fix it, but we'll figure something out. That image is about 4 feet wide. So now we're moving to the main corridor, or the main gallery. We have some things that people can touch and interact with, things that they can open up and learn more about different telescopes in the NSF fleet. We have exhibits about our own telescopes, like this one about NUID, NUID is an instrument on the WIN telescope, finding exoplanets. Has anyone visited McMath before?
I did, but it looked nothing like this.
Oh yeah, it's very different now. Here's some of our own scientists. Well, we got Vera Rubin here, of course, and then also some of our current scientists at work. A few more exhibits there. We have a video that welcomes people to the place, and we did this in cooperation with members of the nation. And part of my job was to run around with a camera up here, getting pictures of flowers and deer and artwork and stuff. And I was like, wow, this is my job. It's really fun. Yes?
Dark energy spectroscopic instruments.
This is the theater where we show Dark Universe.
Beyond 4-meter telescope. For 2 years, Desi swiveled in arms, capture light from our
Ron, you said Rubin and NOIRlab are together now. Is that in terms of, I mean, is that physically and funding wise, or there is separate? There must be separate funding. Could you explain?
I don't actually get to talk about funding issues.
Okay. Okay.
But I can say that you can find that out with a little bit of Googling. So there's some websites that'll help you understand that.
Yes, we're still recording.
You see, we still have some of the original equipment. This corridor was originally used as part of the just as part of the science instrument. The whole building was essentially a big light table. Any other questions?
I actually have one. Um, so you have the data set and you did visualizations of that, the galaxies with the dots that you talked about.
Yeah.
And do the astronomers there or other astronomers, are they able to do like a live fly through on their own computer and you know, to do, I guess, research or evaluation of how the structure is at different distances from the solar system, you know, to the early universe or close?
The answer is complicated because you have uh, millions of data points, and that starts to become difficult to process visually. If you use point cloud objects, it's more doable than not. In the DESI 3-year map, there are 40 million data points. And there's 15 million galaxies, so there's a lot of duplicate observations. But the short answer is yes, they do have ways of doing a subset in a more live, interactive way. So they'll take like a data cube, like an area of interest, and do what's the word? They could stretch or squash certain variables to find out or to interrogate the behavior of dark energy within that cube, just based on the observations that they have. If that makes sense.
Yes, it does.
I've seen some of that happening. It's a little bit beyond my ability. I specialize in stuff that you would play back.
Okay. Thank you.
Um, could it be possible to export just a slice of that data set as a 3D file in OSG, for example, that we could introduce in other planetarium software and travel through?
Yeah, when they release the data for public use, then yes. Then you could excise like a little fan. But to my knowledge, they haven't released that to the public yet. It's still kind of embargoed.
Okay, thank you.
Yeah.
I have one question going back to when you were doing the index of refraction and the lensing. How is that different than what comes out of the camera to begin with?
Well, we're
Don't you
doing
see
it.
the lensing from the image itself?
The difference is that we're using individual objects as lenses. So in the case of the, let me show, let me show this. So in this case, we have many lenses,
Right.
and they're all interacting.
Yeah.
I needed to have a really complex setup. This example that I showed was just a simple single lens. But in this case, imagine this, but many of them overlapping and at different angles.
I guess when I see that, or when I've seen that image, I assume that that came straight from the camera without any additional manipulation. Am I just confused about that, or?
Dale, let me. It's I think maybe it'd help if I got the video. Let's go to noirlab.edu. Let's look at video. Let's search for gravitational lensing. Lens, full dome. Clip from Messengers of Time and Space. Yeah, there we go. So the nice thing that this does for you is it lets you do motion and have this really complex lensing system. So the camera is orbiting this cluster of lenses.
Yeah.
And something I forgot to mention is that it's important that, at least in the setup that I used, it's important that that lens always face the camera. And so it has to face the camera perfectly. So each one of those lens objects has a constraint that faces the camera.
Okay, I didn't realize that it was part of a movie. You probably said that, but it's not just a static image from the camera on the telescope.
Yeah, I'm faking it with CG. And it's quite an exaggeration as well.
Okay, thanks.
Yeah,
It's impressive.
thank you.
Okay, does anybody else have any questions? We're coming up on the hour.
Okay,
Okay.
I have to say that this has been, I think, almost a record for how short the seminar is, but probably one of the very best of all. So, there's something to be said for shortness.
Oh, you're very nice. Thank you. That's very kind.
Thank you, Ron. It's so good to see you again. I miss working with you.
Thank you, Chris. I miss you too.
Okay, so if you want to unmute and give Ron some applause, either visually or verbally or sound, whatever. Okay.
Thank you. I have a lot of people that support me, and I couldn't do it without them. So thank you. Thank you.
So if you didn't sign in, you could do so now. That would be great. And if you want to hang around, I guess we can stop the recording now and have the official seminar over.
I'm here trying to formulate a question. I don't know how exactly I'm going to present this. I've seen some of Ron's work since Planetarium a few years ago. I've never really took the dive into Blender. I was wondering, there are databases of photo movies. There are sites where we can download clips from already produced in video. Is there a database or a website where you can download smaller, not call it clips, but files that we can import into Blender and have some of the work that was already done. For example, for the retrograde motion, you have to put the solar system there. You have to create a solar system so you can do the retrograde motion. Is there some place where you can just get that a basic model of the solar system and expand from there?
We would have to ask, that's a great example. And because that was work I did for NOIRLab, they own the intellectual property of the code or the source that I use to make the product. So you could email me and make that request, and then I would check with Lars and see if he would let me release that. But that's different from what you're asking about. I think what would be a better option would be a repository where all of that is shared. So I don't know if we're in a position to open source it in that way, but if we start getting requests for it, then maybe we would be. NOIRLab leans toward open source, so I think if we started getting requests for that sort of thing, then you might start seeing NOIRLab open up some kind of repository.
Okay,
But
thank you.
There has to be a demand. And
Ron, if something could be developed along those lines, and you could share example files for the different techniques, that would be another great tutorial idea, would be a step through, here's this blend file, here's how it works at this step, and here's at this step, and at this step. I think that would just be a marvelous resource in addition to the files themselves.
Yeah, and I have to also salt this with a caveat, which is that I'm not supposed to talk about or speculate on like future projects. So I can't promise anything. But making that request is something that could happen, and then we see where it goes from there.
Sounds like we need to have an organized campaign of people requesting from